In this problem, a CBS poll was conducted in 2006, and 651 adults were asked about their party affiliation, whether they're Democrat, Republican, or none, and they were asked whether the U.S. economy is getting better, getting worse, or if it's staying about the same. Now, the first thing we have to do is we're given the individual values, but we're not given any totals. So the first thing we have to do is we have to add up the totals. So you have 38, 104, 44, that gives you 186, and so on and so forth. What I recommend is that you put these in your notes because you will see a very similar problem on the homework, and it'll be the same numbers. So the totals are going to be the same, which means it'll save you a little bit of time. So the first question says, what is the probability that if we select a random person, that they have no party affiliation? So remember that probability is going to be the number of successes, however we define a success. So in this case, a success is anybody that doesn't have a party affiliation divided by the total. All right, so let's take a look at how many people have no party affiliation. That's how we define a success. Okay, so no party affiliation, if we look at this row over here, that's going to be a total of 229. And the total number of adults is 651. So for part A, our probability is going to be 229 over 651. Okay. Part B says, what is the probability that if you select a random person, they think the economy is getting worse? So again, now a success is defined as anybody who thinks the economy is getting worse. That's how we define a success. Okay, so how many people said the economy is getting worse? Let's take a look over here. If I look at the worst column, that's a total of 299 people who said the economy is getting worse. So the probability is going to be 299 over 651. The number of successes divided by the total number. Okay, so now part C, it says, what is the probability that's if you select a random person, they said the economy is getting worse given that they have no party affiliation. Okay. Probability that they said the economy is getting worse, and that little vertical dash means given. So given that they have no affiliation. All right, so let's think about this. First off, anytime you have given, whatever that second phrase is, that's going to be the denominator. And not only will it be the denominator, that means it'll also be the sample space. In other words, we're only going to be choosing from the people who have no affiliation. So imagine that everybody else just disappears. So all the Republicans are gone, all the Democrats are gone, and all we're looking at are the people who have no party affiliation. So there's a total of 229 people. And remember, anytime you have the word given, you're only choosing from this denominator. So you're only choosing from this third row. So of those 229 people, we want to know how many of them have no party affiliation. So of the 229, 21 have no party affiliation. So our probability, I'm so sorry. Let's do that again. How many people have no affiliation? That's 229. Now of those 229, how many said the economy is getting worse? Okay, how many said the economy is getting worse? So if you take a look at the worst, that'll be 118. Okay, I apologize. So it's going to be 229 as a denominator, 118 as a numerator. Anytime you have a given, look at the total for that row or that column, and then look at how do we define a success of those no affiliations. So we said anybody who said the economy is getting worse is a success. And how many people said the economy is getting worse? 118 out of 229. And why do we pick 118? Because we're only going to choose from the row of no affiliation. So that'll be 118 out of 229. Okay, so once again, whatever comes after that vertical dash, which is your given, that's your denominator, and you can only choose from that. Part D says, let's flip that. What is the probability that if you select a random person, they have no affiliation given they said the economy is getting worse. Okay, so now you always start with the given. And what is the given in this case? The given is that they said the economy is getting worse. So that's your denominator, that's your given. So how many people said the economy is getting worse? So if I count the number of people who said the economy is getting worse, that's 299. And because we're given that we're choosing from the worst column, we can just ignore the better column and ignore the same column. So we're only choosing from those 299 people. Imagine everybody else disappears. We're only choosing from those 299 people. Now of those, how many of them said they have no affiliation? And that's 118. So our probability is going to be 118 over 299. Okay, let me repeat that. How many people said the economy is getting worse? That's your given, so start with that. Always start with the given. That's your denominator. That's 299. Of those 299 people, and we don't care about everybody else, we're only going to care about the people who said the economy is getting worse. Of those 299 people, how many of them have no affiliation? And that's going to be 118. Okay, last one. It says, what is the probability of choosing someone who has no party affiliation and said that things are getting worse? So first off, if there's no given, your denominator is everybody. So your denominator in that case is going to be 651 because we have no given. If there is no given, you're choosing from everybody. Now, of the people, so from everybody, so of those 651 people, how many of them have no affiliation and said things are getting worse? Now remember, and is an intersection. So what we're looking for is we're looking for the intersection of neither party and worse. So we're looking for this intersection. So here we have neither party. Here we have worse. Where do they cross? They cross right there at 118. You're always looking for the intersection when you have the word and. They cross at 118. And what is the denominator? It's going to be 651 because we're choosing from everybody. So our probability is going to be 118 over 651. Okay, the next example, it says the correct size of a nickel is 21.21 millimeters. Based on that, a bunch of kids were asked to draw a nickel. Now, some kids drew it too small, some kids drew it too large. No one obviously can draw 21.21 millimeters. That's very hard to do. So these kids, they either drew it too small or too large. And then these kids were split up by their income level. So they were classified as low income or high income. Okay, so part A says, find the proportion of children from the low income group. Now, from, what we're saying is that we're only going to be choosing from that group. So think of from as given. So we want the proportion of children from the low income group that drew the nickel too large. So basically, here's what we're looking for. We're looking for the probability of choosing somebody that drew the nickel too large. But remember, we're only choosing from the low income group, given that they are in the low income group. And again, we're choosing from the low income group. So because we're only choosing from the low income group, that's the row we're going to focus on. We're going to focus on those 40 kids. Okay, so how many kids are in the low income group? 40. And of those 40, how many of them drew the nickel too large? That's 21. So it's going to be 21 out of 40. Okay, now part B says the proportion of children from the high income group. So once again, we're only choosing from the high income group. So now we're going to focus on the row that is the high income group. Okay, how many people are in the or how many kids are in the high income group? That's 35 kids. And of those 35 kids, how many of them drew the nickel too large? 12 of them. So your probability is going to be 12 out of 35. So only from the high income group, that's all we're focusing on. 12 kids drew the nickel too large out of a total of 35. Part C says the proportion of all children who drew the nickel too large. Okay, we're now looking at all children. So all children, that's all 75. So we're looking for the total. So your denominator is going to be 75 because we're looking for all children. Now, of all children, how many of them drew the nickel too large? And that's 33 out of 75. Okay, lastly, part D, it says, if a child is picked at random, what is the probability that they are in the low-income group given they drew the nickel too large? Okay, if a child is picked at random, what is the probability that they are in the low-income group given that they drew the nickel too large? So start with the denominator. Okay, focus on that. How many kids drew the nickel too large? That's your given. So we're only going to focus on the kids who drew the nickel too large. We're going to focus on this column. So the denominator is going to be 33 because 33 kids drew the nickel too large. That's your given. Now, of those 33 kids that drew the nickel too large, how many of them are in the low-income group? And that's 21. So the probability is going to be 21 out of 33. So always start with the given, that's your denominator, and only choose from that row or that column anytime you have the word given.